Hello and welcome back. My name is Sarah Beyer. I'm a Kansas City-based native landscape consultant with Oak&Io. Today's webinar is the second in an ongoing series, a partnership with Mid-America Regional Council and Deep Roots KC. The series is underwritten through a grant from the Health Forward Foundation, and we're thankful to them for their support. Today's topic is soil. We see it every day, but how much thought do you really give to it? Today, we're going to look at soil systems, find out what makes them work and how we can support healthy soil systems. Once you dig into the ground beneath your feet, you're never going to look at it the same way again. So let's get started. Okay, so first of all, just a little overview of the topics that we're going to talk about today. First, we'll start with a definition of terms so that we have some shared vocabulary to be able to talk about soils with. We'll talk about how soil provides for us, and then we'll talk about how we can support healthy soil systems. So what is soil? Might seem like a little bit of a silly question. How is it different from dirt? We see soil and dirt all the time, and our language can lead to some confusion here. We do use them interchangeably, and one may resemble the other, but there are a few key differences. Soil is full of life. Soil contains living organisms. Soil has structure. It forms these layers called horizons that you can see in the photo there. Soil is in place. It is found in place. Dirt, on the other hand, is not in place. Dirt is what you track into the house or wash out of your clothes after working in the garden. Dirt does not have life. Dirt does not have structure. Dirt is soil out of place. Soil forms very slowly. Depending on where you are in the world, it may take from 100 to 1,000 years to build 1 inch of topsoil. Dirt, on the other hand, if you have kids or pets in your life, you know that dirt happens quickly. The Soil Science Society of America defines soil as the surface mineral and/or organic layer of the earth that has experienced some degree of physical, chemical, and biological weathering. This definition gives us some framework to talk about a little bit of the vocabulary that we'll use throughout the talk today. Let's first visit mineral and/or organic and talk about those. So looking at minerals in the soil, maybe things like potassium, iron, calcium, magnesium, all of these are present in the soil. They get there through dust, through from the parent material, the rock that the soil was formed from. The organic matter in the soil includes dead and decomposing plant and animal matter, soil microbes, and the substances that soil microbes produce, carbon, oxygen, et cetera. We'll talk a little bit more about that in a minute. The range of organisms in soil is so great that it's estimated that they represent about 25% of the world's total biodiversity. There are more organisms in 1 teaspoon of healthy soil than there are humans on the planet. And remember from our last webinar, organism simply refers to a single living entity. So you can get an idea of both how small they are, how important they are, and how incredibly diverse they are. So we'll need some vocabulary to talk about this microscopic life in the soil as well. So when we say microbe or microorganism, we're talking about, that's the term for 1 microscopic organism. They are too small to be seen without a microscope, and they exist by the billions in just a small amount of healthy soil. And they're really critical to plant survival and therefore to all of our survival. We also may use the term microbial community when referring to a group of different microorganisms all existing together. We'll talk about 2 main types of microorganisms for today's talk, bacteria and mycorrhizae. So bacteria are single-celled organisms. Contrary to our common language, bacteria aren't necessarily bad, and there are far more types of beneficial bacteria than the small number that cause disease in humans. Mycorrhizae are microscopic fungal networks that grow in association with the roots of plants. So it's a tiny hair-like fungus that grows in and around the root of the plant. So back to our definition briefly. In addition to containing the mineral and the organic material, our soil has experienced some degree of physical, chemical, and biological weathering. So if we imagine starting with solid rock, the weathering is what helps us get to something that we can call soil. So our physical weathering, first of all, if you think about the freeze and thaw cycles, our city potholes are a good place to think about where you've seen that happen. So water seeps into a crack in the rock, or in this case, the road. Then when it freezes, water expands as it forms ice. So it is physically pushing and cracking that rock apart. And then through those cycles, the thaw, you get more water in, the water gets deeper in, the freeze pushes it back apart. And so that repeated over the many years, over seasons, creates smaller pieces out of those larger rocks. You may also have abrasion by water or wind. Basically, the constant scrubbing of loose material by either waves or by wind breaks those larger pieces into smaller and smaller pieces. And you can see that in the smoothness of stones that you may find at the beach. They've been rolled and tumbled against each other, causing the sharper edges to break off and smoothing them down slowly and slowly over time, smaller and smaller. So our chemical weathering may include things like acid rain, as you can see there at the top. So as water falls through the atmosphere, it picks up acidic compounds, and these slowly dissolve the rock, where you get this pitting type appearance. You can see this a lot in areas like Kansas City, where you have a lot of limestone, which is particularly able to be dissolved by that acidic rain. The red rocks that you may associate with the American Southwest, that red color occurs through oxidation, basically the reaction of the iron within the rock to the atmosphere forms rust and does slowly weather the rock, as well, as you can kind of see at the bottom of that picture. And finally, our biological weathering. So plants create weathering by growing in cracks. Their roots are not necessarily particularly large, but they're strong and they're persistent. And so plants do open existing cracks, they create new ones. They also allow for some of that physical weathering, the freeze-thaw cycle. They allow water to get deeper into those cracks as well, so that these processes are working in concert together. And we have animals as well that may burrow or dig through soft rock, which create pieces of smaller sizes and also open up new areas to the physical and the chemical weathering. And our last definition, pore space. So healthy soil has about 50% empty space called pore space. This is where air, water, and microbes live within the soil. They have to have room. If you don't have that pore space, you can't hold anything in your soil other than the bits of soil itself. So we need spaces for the air, for the water, and most importantly for our life, which also needs the air and the water. Soil is, if you haven't already guessed, essential to life on Earth. We need soil, sun, water, and air to grow plants. These in turn sustain all life on Earth, including ours. Soil plays a critical role in our food, our clothing, if you think about cotton clothing there, our shelter, whether that be through wood or through bricks, or 50% of the world's population lives in homes made of soil. Soil provides us places for recreation and enjoyment. Soil cleans our water by physically filtering out pollutants. As water moves through the soil, those things are left behind, and healthy soil can filter and clean a lot of our water. Soil also stores carbon, which decreases the carbon level in the atmosphere that contributes to climate change. Soil changes over time. It's built very slowly. It can be depleted very quickly if we're not careful and we're not caring for it. So plant roots remove water, remove nutrients, the things that the plants need. That's coming out of the soil and needs to somehow be replaced. Water and wind may erode or carry material away. Human use of synthetic fertilizer and pesticides kills our microorganisms that are needed for soil development. And human and animal activity compacts soils. In that top picture there, you can see a lot of that happening. That eliminates that pore space for nutrients and water to be stored in the soil. Unfortunately, this precious resource is underappreciated and often abused. In the United States, we are losing soil at about 10 times the replenishment rate. So 10 times faster than we're building soil, we're losing it. Obviously, that's not sustainable. Loss of topsoil currently costs the United States about $44 billion per year. So let's dive into soil systems, find out how they work, and then we can talk about how we can support healthy soil systems and help counteract some of that loss as well. So if we look at plant roots, we see that even very deep roots have a root absorption zone that is limited just to the area right around the root, and even this circle may be too large in some cases. So plants need water and they need nutrients, and only being able to absorb from that small zone, they would really use up what is present just right around that area very quickly. In addition, the plant's root tip may be too large to reach into the smaller spaces. Remember that about 50% of healthy soil is the spaces in between the solids. So in order to survive, plants have co-evolved a symbiotic relationship with fungus and bacteria in the soil. Bacteria feed the plant roots nutrients. So they're kind of like a little delivery truck that goes inside the root, releases the nutrient, and then is pushed back out. Mycorrhizae provide the transportation system, the highway for these deliveries. So when the system is functioning well, a plant can actually call for a specific nutrient that might be present in the soil 100 feet away and receive it in seconds. So in this example, we've got boron, which is a nutrient that plants need, but in very, very tiny amounts. And it's not necessarily evenly distributed in natural systems. There may be quite a bit of it here and almost none over here, but that's where this system comes in to deliver the boron that the plant needs to the plant. Plants then put glucose into the soil. Glucose is a sugar that contains carbon, and it feeds the microorganisms. Basically, the plant is sort of purchasing these services, the goods and services, purchasing the boron, purchasing the transfer of the boron and other minerals as well, by exchanging that carbon, by feeding the microbes. In this way, plants put carbon back into the soil, which helps fight climate change. Now, this system is probably not intact in most yards, in most human-dominated places, but we can support and rebuild it. When we do so, we get healthier, more disease-resistant plants. We get soil that can absorb and filter more water, soil that's less likely to erode. We get less flooding, and we get more carbon out of the atmosphere and stored in the soil where it belongs. So how can we improve our soil? Ultimately, plants can improve the soil on their own, but we need to support them in doing so. So we're going to take a look at this framework of principles of healthy soil management, which is from Jay Fuhrer, an NRCS soil health specialist. And I'll have a link to his work in our supplemental materials as well. I encourage you to dive into those if you're interested in learning more details, because you can certainly, there's much more here than we'll have time for. We'll kind of scratch the surface, as it were. So our first principle is a living root. So using a diversity of perennial plants, those are plants that return year after year, maximize the presence of those living roots all year round. If you contrast this with a bed of summer annuals that will die at the end of the season and have to be replaced, you can see how there's a marked difference in whether we have those living roots in the soil. Focusing on those living roots year round supports that soil system year round. It decreases potential for erosion, decreases the need for disturbance in the replanting all the time. And we'll talk about that a little bit more in a minute. Next, we have soil armor. Soil armor just refers to having something covering the bare soil, protecting it from wind, from erosion, helping to regulate its temperature. You can see some options here. Note on the decorative stone, it can get too hot and can be damaging to microbes. So if you have that stone out in the blazing sun, like it's shown in that picture there, that can become a problem. If it is included below like a really heavy plant cover where it stays shaded, it can work pretty well. Compost can be a good mulch. It adds organic matter to the soil, which may be needed. Wood mulch, a light wood mulch is better for most applications than a heavy wood mulch with thick chunks. It's important to pay attention to the natural environment of the plant when you're selecting a mulch. And we'll talk more about this later in our webinar series. You may also want to use a green mulch, which is another word for ground cover. So green mulch, the majority of what you see here in this picture is roundleaf groundsel or Pachyra obovata. It's a native ground cover that, as you can see, has filled in around all the other plants. Those leaves they're the ones that kind of look like, I think they look a little like baby spinach leaves. Those leaves are present and green almost all year round. So they are covering and protecting the soil. There are several native ground cover options which exist and can help eliminate the need for additional mulch as your garden matures. So keeping that soil covered keeps soil temperatures cooler in the summer. And this supports that microbial activity, keeps them cool and happy. And it actually cools the microclimate in the area around the garden. If you imagine standing in the middle of a circle of, just wood mulch or those decorative rocks or of concrete, it's much hotter than if you step off, onto something green. So if you're interested in some supplemental materials, take a look at that. You can kind of extrapolate this effect to an entire region, and you can actually start to affect local weather in multiple ways by caring for the soil. And so I've got some material on that for those of you who may be interested in learning more. Looking at plant diversity, you may remember our little drawing here from the last webinar showing the different types of plants, different root depths, different root diversity, including a wide variety of plant species, attracts and supports a diversity of insects and birds, which bring with them additional nutrients. So they are doing what birds do when they come sit in your garden. They're contributing excretions to the soil. The insects that perish in your garden for one reason or another are adding their organic material to the soil in the form of their bodies, their exoskeletons, and that feeds that soil community. So contrast the diversity on the left here with that on the right. On the left, we can see there's 2 to 3 species in bloom in the foreground here, and many others are layered in between those and beyond up closer to the house. This garden provides wildlife value all year round. So it's attracting that diversity of insects and birds, which are bringing with them the nutrients, bringing with them additional microbes that all help to add to that diversity of microbial activity in the soil. On the right, we see just a couple of species of annuals. Looks like they're all currently in bloom. They're going to require removal and replanting as well. And so that brings us to our principle of least disturbance, which is the next one on the list here. So while it's definitely sometimes necessary, disturbance can cause a loss of organic material. Being exposed to the air allows carbon to escape the soil. It can cause the death of beneficial microorganisms, including the bacteria and the mycorrhizae that we looked at earlier. And when that microbial community collapses, then more inputs are needed to fight the disease that community naturally protects the plant from, to help provide the nutrients to the plant, since you don't have that transportation system bringing them to the plant. And then those synthetic fertilizers and weed killers and antifungal sprays, all of those things that we're using to make up for the fact that the microbe community is not healthy, further cause the collapse of the microbial community. Those things kill the mycorrhizae, they kill the bacteria that we need. So it's really a vicious cycle once you get into it. And finally, we see the degradation of the soil structure. It may be compacted where the pore space is compressed and there's less air and water held in the soil. When that happens, we see more flooding, more erosion. So it's important to avoid disturbance, minimize it whenever we can, and to help rehabilitate the soil after that necessary disturbance that may have to happen from time to time. And finally, animal wildlife integration Healthy plants in healthy soil attract a wide variety of wildlife, provide food at many different levels. You have a diversity of inputs from these animals that we talked about in the form of excretion, in the form of adding their bodies to the soil. And this all adds to the diversity present in the soil. The presence of ruminant animals, grazers like goats and cattle, can also have a really positive impact on soils when properly managed and moved frequently. And I'll have some additional information as well in the supplemental materials on that. So as you may have seen, kind of once you start to dig into soil a little bit, you can just keep going and learning. There's so much science out there. So I encourage you, if this is something that interests you, to take a look at those as well. So what do we do with this information? I've got a soil health checklist for you to keep in mind whenever you're making decisions involving the yard or the garden. So the first thing we want to do is increase the diversity of plants. We want to focus on native species. If you remember in our previous webinar in the series, we discussed co-evolved relationships. These exist between native plants and native microorganisms as well. So they are co-evolved symbiotic partners and rely on each other. So focusing on those native species wherever you can to help support the native community of microorganisms in your soil. Add biological factors, so add living organisms where you can. So this may be compost tea, it might be purchasing mycorrhizae. In these things as well, consider the source. You may be able to find, depending on where you are, native mycorrhizae to add to your garden when it's newly planted, or if you have a new project going on or want to just improve your soil health, that might be a way to do it. Protect the soil with mulch. So you want to give it that soil armor. That can be a ground cover. This can be a green mulch. It can be just a standard mulch. We do want to try to allow it to function as a living part of the garden if we can. And again, we'll talk more about that as we move forward in our series. And we want to minimize disturbance. If construction is necessary, we want to minimize the impact as much as possible. We want to keep heavy equipment off the soil as much as possible, and take some of the supportive steps that we're talking about after the work is done to help minimize the impact of that disturbance and help the soil to regenerate and recover. And finally, we're going to test and balance minerals only when necessary. So we tend to get amendment happy and start kind of tinkering and looking at the pH and thinking that we need to add things to the soil if things are not growing properly. But this may be a secondary step, and it may be that you don't actually need to do much of anything there at all. A lot of these other factors and having those living biological components to the soil can, in a lot of cases, be more important than the minerals if your minerals are not really out of whack. So again, I'll have some soil testing resources in the accompanying materials to talk about how and where to do that. And finally, remember that soil forms slowly, but soil health can change relatively quickly. Just a year or two can have you start seeing some positive changes if you take some of these steps and start considering the impact on the soil's health and supporting it as much as you can. If you'd like to learn more, we have further resources available for you. So the supplemental materials that accompany this webinar can be found either on the Mid-America Regional Council or Deep Roots websites. Be sure to check out the next Planet Native conference at planetnative.org for more information on native plants and soil health, and a couple of soil specific resources for you: Kiss the Ground at kisstheground.com and Soil Health Academy.org are two nonprofit organizations committed to soil health that have resources available, both paid and free, for you to learn more. And those will be in our supplemental materials as well. If you have questions, you can contact Mid-America Regional Council or Deep Roots with the information that you have on your screen. I want to thank you for joining us and hope that you will come back next time as we continue our series Many thanks to the Health Forward Foundation for supporting our webinar series. We are grateful for their support and look forward to the next one.